Let's understand what's actually happening physically. Why is the decay actually faster? It's easy to understand just by a picture. So if we plot m dot as a function of m, so the equation again is that m dot of t is equal to minus rm of t minus tau. Now if there was no tau present, then we would just have m dot as minus rm of t. So it's a straight line with slope minus r. So if we're at a particular value, if there was no delay, if here was a value m of t, then we would go to the line minus r, and this would give us m dot of t. However, if we have time delay in the system, then if we have m of t, we don't go to the curve minus rm, but we go to the curve minus rm of t at an earlier time. So if m of t is decaying exponentially with time, then at some earlier time, m is larger. So this is m of t minus tau, and so that means that m dot of t is proportional to minus rm t minus tau, so it's actually bigger. So what that means is that if I'm at a given point on this line, eventually converging to m equals 0, I'm being pushed by a stronger force than if there was no time delay. So this is what gives rise to a faster approach to the equilibrium state. If tau is too large, then m dot can be very large and negative, leading to a sign change in m itself, which leads to instabilities. So based on the phase portrait of m dot as a function of m, we argued that the approach to the final state could be monotonic or it could be oscillatory. So let's now look at the behavior of m as a function of t as we change the time delay. So for no time delay, we just have pure exponential decay. But as we increase the time delay, very gradually the approach to the final state is slowing down, and we reach a point where there begins to be a bit of an overshoot and m goes below 0 before it finally approaches the final value m equals 0. And as we increase the time delay further, now something really amazing happens because one sees really clear oscillatory behavior superimposed on the exponential decay. And as the time delay approaches a special value of pi over 2, one can see that what one gets in the equation of motion is nothing more than the equation of motion for the sine function. So it turns into a perfectly periodic function. Beyond pi over 2, instead of having oscillatory decay, one has oscillatory growth that grows without bound as the time delay increases.